we will never be able to go to other stars. At least, it often seems that way when you begin to delve into the current state of the technologies needed for it, or into the huge pile of problems associated with interstellar travel. There are indeed a lot of problems, and not all of them are related to the vast distances, but we most often talk about that. The theoretical solutions to this problem generally involve creating engines that could achieve a significant fraction of the speed of light in order to reduce the travel time to even the nearest stars from tens of thousands of years to at least hundreds of years. There are of course also warp drives, which I discussed in more detail in a separate video. These are not outright denied by physics and in theory could allow for the faster than light travel across the universe. But despite some progress in theoretical research, they are still much closer to science fiction than to reality. If they are ever developed, it is likely to be hundreds if not thousands of years from now, if humanity even survives until then. But in science fiction, alongside warp drives, there is another popular trope describing a solution to the problem of long interstellar journeys. Human hibernation, putting a person into a special state in which they essentially sleep for most of the space journey. In movies and books, people can remain in this state for decades without aging. At the end of the journey, they wake up and recover quickly. Probably one of the first examples in fiction that comes to mind is Alien franchise, or 2001: A Space Odyssey. So maybe the key to interstellar travel isn't trying to create a warp drive or using something like wormholes, but rather employing more conservative methods of space travel, especially since accelerating to a few % of the speed of light is quite feasible, and combining this with hibernation. I've already talked about potential engines such as light sails and others in separate videos, but what about the second part? How close are we to inducing hibernation in humans for long space journeys? Is it even possible, and what problems does this concept have? And by the way, right now, two major space agencies, NASA and ESA, are conducting research into human hibernation in one form or another. Let's talk about all this and more. I'm Andrei, and this is Cosmos Elementary. So, it's quite clear why there is an effort to develop such a technology for interstellar travel. Today we're primarily discussing a realistic scenario and how soon we might be able to create something like this. There are already some developments here, but they currently aim to create such a system not for interstellar travel, whose future is highly uncertain, but for travel within the solar system. But why is this even needed for the solar system? The distances here are not comparable to interstellar ones. Moreover, if people do travel to somewhere beyond the moon in the relatively near future, that would be no farther than Mars. But given the capabilities of current engines even to the neighboring red planet, the most efficient trajectory would take 9 months, or at best 7 months. It is certainly not tens or hundreds of years. But even such a journey through interplanetary space presents for us, fragile humans, a host of problems. They concern physical and mental health. Additionally, having people on board significantly complicates the spacecraft design, requires certain systems, and increases its mass. If all or most of the people on board were asleep for the entire journey, and if such sleep were safe for them, they wouldn't have to spend several months confined in a very limited space. This could help avoid stress and, surprisingly, perhaps even help protect from radiation. Of course, it would also significantly simplify the spacecraft's design, make it smaller, and make launches easier and cheaper. I will tell you more about this further using specific studies as examples. By the way, among them there are some quite recent ones. There are still many questions regarding the exact state to put a person in and also how exactly to do that. For now, we will just dismiss cryonics, as the cells in our bodies which contain water don't really like being frozen. The crystallization of water and other adverse effects can cause irreparable damage to organs, and as far as we know, it is currently impossible to fully freeze and then unfreeze a human being. But cooling is possible, and there are different states of reduced metabolism. When scientists and engineers discuss the possibility of using hibernation for space travel, they typically use 2 points as motivation. Firstly, the ability of a range of animals from different species and sizes, including those relatively close to humans, to enter hibernation. And also some cases where people seem to be in conditions of hypothermia, where they basically should have died, but somehow they managed to survive and even fully recovered. Additionally, in medicine, therapeutic hypothermia is currently used, which can slightly slow a person's metabolism down and, according to some data, has beneficial effects on patients' health. In summary, some potential benefits of using some form of hibernation for space travel, examples from the animal world and existing medical practices have prompted some scientists and engineers to work on real projects of human hibernation. And now let's dive into the details. So, some animals have various states of reduced metabolism, and also someone at some point apparently managed to survive in the cold. Why do we think that we will be able to induce some form of hibernation in humans at will? So, imagine you measure the temperature and worry that it might be elevated. But what if thermometer shows not 37.8 Celsius or 100 Fahrenheit, but 17.8 Celsius or 64 Fahrenheit. That doesn't seem to be a good thing either. But that was exactly the body temperature of Aubrey Mash when she was brought to a Spanish hospital. She had been caught in a snowstorm in the mountains. She was brought to the hospital with cardiac arrest and such a low body temperature. Her heart had stopped beating for 6 hours. However, the doctors managed to save her, and she later made a near-complete recovery. Doctors believe that while the cold nearly killed her, it also saved her. The significantly lowered body temperature prevented fatal damage to the brain and other organs, and this is not the only similar case. Anna Bågenholm was skiing when, as a result of an accident, her head and torso became trapped under a layer of ice. Her friends were unable to rescue her and called for emergency services, which took 80 minutes to reach and save her. During this time, she managed to find an air pocket under the ice which allowed her to breathe and even remain conscious for a while. But eventually, she stopped breathing. Her blood circulation ceased and her body temperature dropped to a record 13 degrees Celsius or 55 Fahrenheit. Nevertheless, she survived after being in that state for several hours. And the most astonishing case, which is perhaps the hardest to believe, is that of the Japanese man Mitsutaka Uchikoshi. In 2006, after a barbecue with friends in the mountains, he decided that instead of going back by car with friends, he would just walk back, alone. On the way, he got lost, slipped, and fractured his pelvis. He remembers the first 2 days, but then he lost consciousness. He was missing for 3 weeks, and 24 days later, passing climbers found him. His body temperature was about 22 degrees Celsius or about 71.5 Fahrenheit. His pulse was barely detectable. He had lost a lot of blood and many of his organs were failing. By the time he was taken to the hospital, his fracture was already healing. This case still astonishes doctors and scientists. If everything happened as reported, it means that he was unconscious for 24 days without food or water and survived. Most importantly, he later made a full recovery. Many consider this impossible. But some people claim that hibernation can explain this unusual case. It is suggested that in extreme conditions, when Mitsutaka's body temperature could have dropped to as low as 10 degrees Celsius or 50 degrees Fahrenheit, some protective mechanism in his brain induced a state similar to hibernation. His metabolism significantly slowed down and his body needed much less oxygen. During this time, his organs and brain avoided long-term damage. Some details are still unclear, such as whether he truly entered a form of hibernation and what the mechanism behind this might be. However, if this is the case, it could suggest that this mechanism exists in us, and we only need to learn how to activate it, and, of course, ensure that it is safe. This extremely dramatic story has to be approached with caution, but as I mentioned, there are many similar examples. While not as dramatic, they are better studied. However, these are all accidents. But we have been cooling people on purpose for a long time. During surgeries, the bodies of some patients are cooled down to 18 degrees Celsius or 64 Fahrenheit. This slows down the processes in the body and reduces the risk of brain damage. Therapeutic hypothermia has been used by doctors for several decades now. Here, the body temperature is lowered to a lesser extent, typically a few degrees, down to 35 Celsius or sometimes 32 Celsius. This cooling is used in various situations, such as head injuries, neurological trauma, stroke, and cardiac arrest. This method improves recovery and reduces mortality after certain conditions. Patients can be cooled in various ways, using ice or infusing special solutions. There are many nuances involved, but can such a method place a person in hibernation for an extended period? For example, there were Chinese experiments that tested the effects of long-term hypothermia on patients with brain injuries, with the longest period being 2 weeks. Apparently, no complications were observed, and there were even data suggesting a possible positive effect, although the sample size was small. Moreover, the same patients were put in this state multiple times and no negative effects for their health were reported. As for animals, many enter states of hibernation and suspended animation, and these states can vary. They can be spontaneous, occur due to worsening conditions or food shortages for survival, or happen on schedule, as with bears. Animals lower their body temperature, slow their heart rates, and thus reduce energy consumption. In some cases, their metabolism can drop to 2% of its normal rate and last for several months. Interestingly, the exact mechanism responsible for this in animals is still not well understood. There isn't a specific switch identified, although certain areas of the brain are under suspicion. There have been experiments where mice were induced into hibernation by affecting them with certain substances. But is it possible to induce a state of hibernation in animals that naturally do not enter such a state? In 2022, an experiment was conducted, with the article published in Scientific Reports, where, for the first time, rats, animals that do not naturally hibernate, were induced into a state similar to hibernation. What if humans also had this mechanism that could be potentially activated using some chemical substances? Could we enter a state of slower metabolism not just through cooling, but also by signal from the brain, similar to how hibernating animals do? Scientists do not rule out this possibility. It is possible that Mitsutaka Uchikoshi's brain sent such a signal. Experiments on rats indicate some progress. Though there are studies suggesting that for humans with our body mass, such hibernation might not be very effective, and slowing down metabolism may not result in significant energy savings. On the other hand, we have the example of bears. They lower their body temperature only slightly compared to other animals, and lose relatively little mass over months of hibernation, recovering quickly afterward. In summary, a form of human hibernation that would be useful for space travel is theoretically possible, but much more research is still needed. Some existing projects use more conservative methods, and let's talk about them. A company called SpaceWorks is developing a hibernation system for a mission to Mars. Its CEO is John Bradford. Back in 2013, their presentation caught the interest of members of NASA's Institute for Advanced Concepts. SpaceWorks received an initial grant of $100,000 to develop the first phase of the project. There is a comprehensive document available to the public that contains all the details of the first phase. Based on ISS modules, they developed a module designed for astronauts for the spacecraft to Mars. This module has a closed-loop system for producing oxygen and water. There is a direct access to the equipment for landing on Mars and ascending from it. The module can accommodate a crew of 3 to 6 people, and since the mechanism for true hibernation is not yet available to us, it is proposed to induce a similar state in people through cooling, as is currently done by medical professionals. As an option, cooling nitrogen could be administered through the nose, lowering the brain and body temperature to a range between 35.5 and 31.7 degrees Celsius, or between 95.9 and 89 Fahrenheit. In such an artificial hibernation, the entire crew could be in a dormant state, or one crew member could stay awake to monitor their colleagues and the ship's systems. The crew members could take turns being awake in shifts. Another question we haven't addressed yet is how and what the sleeping crew members will eat. Parenteral nutrition is suggested here, where all necessary nutrients that replace both food and water are administered intravenously. In the paper on the first phase, the authors mentioned that the total parenteral nutrition has been used on Earth for periods extending a year. This practice is well established in medicine and could be quite suitable for this application. Naturally, the condition of the space travelers would be monitored by numerous sensors, and robotic arms could perform various manipulations on the equipment. The system would send electrical impulses to stimulate muscle activity, among other things. The paper stated that all the basic systems for cooling and nutrition were available at the time, but they were either manual or semi-automatic. Ideally, fully automated systems need to be developed. In addition to the aforementioned benefits, such as avoiding the need to remain conscious for months in a confined space with all the associated stress and issues, a major advantage of the system is the significant simplification of the design and reduction in mass. Compared to more standard NASA projects for Mars spacecraft modules like this one, the SpaceWorks module could be up to 52 or even 68% lighter, depending on the parameters. Its size could be smaller, requiring less bulky equipment. Alternatively, for the same mass, it could potentially double the crew size. Later, SpaceWorks even designed modules for up to 100 or even more people. The story of the SpaceWorks project didn't end with the first phase. In 2016, they received a second grant for $250,000. However, there some difficulties arose. SpaceWorks wanted to conduct hibernation tests on pigs, which are physiologically similar to humans, but they were not permitted to do so. Work on the second phase of the project appears to be ongoing. The second study conducted by the European Space Agency is also relatively recent. The motivation is similar, but the approach is different. The relatively conservative approach of cooling, similar to medical practices used by SpaceWorks, does not provide one of the main advantages of true hibernation, the radical slowdown of metabolism. If it were possible to achieve this, in addition to reducing structural requirements, it would also significantly cut down on the resources needed to sustain humans' lives. With less food and water required, the overall mass decreases, making the mission significantly cheaper. Their capsule design is also different. It resembles a large soft shell that does not restrict the astronauts' movements, maintaining a temperature below 10 degrees Celsius or 50 degrees Fahrenheit and high humidity. The astronaut is dressed and equipped with sensors to monitor vital signs, and AI systems manage all this data. Additionally, each capsule is surrounded by a water-filled shell, which is intended to provide protection against cosmic radiation. Even on the ISS, people are exposed to higher levels of radiation, despite the station being within the Earth's protective magnetosphere, but outside of the main mass of the atmosphere, which also protects against harmful particles. For long interplanetary journeys, dangerous high-energy particles originating from the Sun, as well as from beyond the solar system, and even from the outside of the galaxy pose a significant threat. Spaceships need to be equipped with additional protection, which makes them even heavier. And here's an interesting thing. It was observed that in animals, in a state of hibernation, effects of radiation are reduced. The exact reason for this is not well understood, although there are some theories. When harmful ionizing radiation affects the body, free radicals are produced, and they damage the body's cells. Reducing metabolism leads to lower oxygen consumption and appears to have the opposite effects. It reduces cell mortality and extends their healthy lifespan. This effect is even more pronounced at low temperatures. So, if a way to induce true hibernation rather than just medical cooling can be found, it could at least partially solve another problem in human space exploration. Also, true hibernation like that of bears could protect against muscle atrophy and bone density loss, which are typically observed in patients who are bedridden for months. However, the main problem with the European Space Agency's approach is that we do not know yet how to achieve such a state for humans, although, as I mentioned, it is not considered impossible. The idea is certainly intriguing and exciting. If we consider the SpaceWorks option, it seems quite realistic. For now, no one is planning to put people into a deep sleep for hundreds of years on starships. However, the image of a person lying down in a capsule, falling asleep, and waking up at another planet might not be limited to science fiction, but could become a reality in the not-so-distant future. Thanks for watching. Links to all of the sources and papers are as always down below in the description, and if you enjoyed the video, don't forget to subscribe for more videos in future, and leave some likes, comments, and share this video with your friends. Thank you. Goodbye.